Let us understand how to provide domain range of exponential function. So we have a very complicated example to deal with. The question is domain and range for function f of x equals to 1 minus 3 to the power of minus 3x minus 6. So you can pause the video, copy the question, write on your answer and then check with my suggestion. Now, when we are looking into these kinds of function, it's a good idea to write the function in kind of factored form. So let me write down this function in a different way. So I'll kind of give it like this. Let me write it big and bold so it's very clear to you. So first factor will do minus. I'm rearranging it, right? And writing this as 3 to the power of, I'll factor out minus 3, right? So we get minus 3. When you factor minus 3, you get x here. And 6 divided by minus 6 divided by minus 3 will give you plus 2, right? So that is just function, and plus 1 I'm going to write here. The reason is when you do transformations, it is better to do multiplications before addition and subtraction. So we kind of rearranged it. Now if I do operations from left to right, I'll follow a proper sequence. So that's the whole idea. Now we could have given answer directly, but I'm trying to show you using transformations how to sketch and then get into domain range, right? So let's just sketch this function. Let's say this is our xy axis, the coordinate plane, and we'll start with the base function, which is 3 to the power of x, and let's see how will that base function get transformed into this final f of x, right? So we have here 3 to the power of x. Let's say this is our function, which is kind of, let me write this as 3 to the power of x, right? So obviously good point to note is this, which will of course be 1 when x is 0, and another good point will be if I have 1 here, for example, then this point should be 3, right? So at 1 I have this point as, so let me write here, let me write 3. I know this is not to the scale, but well, it will work for us. Correct. So we have this first function, which is 3 to the power of x. Now if I do minus, right, so if I'm doing this operation of minus, it basically means that you have to reflect it on x-axis, right? So this point, which was at 3, comes down to minus 3, right? So this will be here at minus 3. So we can draw this function and 1 will be at minus 1. So that is what it should be. So the function will get reflected and we'll get a graph which is kind of here, and I can write this as minus 3 to the power of x. The next step is, let's get back into the bracket, and whenever you are in the bracket, you are doing everything which is horizontal in nature, right? So first step is reflection. This is reflection on the y-axis. So they flip. So instead of minus 3 at 1, this minus 3 comes at minus 1, right? So this comes at minus 1, and well, this remains there where it is, and so now we have to reflect it. So what I will do is we can kind of sketch this graph as coming from this side now, right? So let this be minus 3 for me, right? So this function is minus 3 x to the power of minus x, right? So minus x. Now when we divide by 3, this is horizontally compressed by a factor of 1/3. What we really do is we take these points inside. So now we'll have minus 3 value at 1/3 its value. So this will be at minus 1/3 what you're going to get, right? But 0 times anything is 0, so that remains kind of same. So everything kind of moves in by 1/3 of the time, kind of like this. Do you understand? That's how it is. So we kind of get a graph which is, I mean, it's not very accurate, but anyway, it will be something like this, right? So this graph is 3 to the power, this is negative, right? 3 to the power of minus 3. So we compressed it horizontally by a factor of 1/3. And the last stage is to move it 2 units to left, right? So that will be our final graph, moving it 2 units to the left. So let's do it with this ink. So now 2 units to the left will be that this point actually moves in 2 units to the left. So we get this point here, right? And the other point, which was at 1/3, now goes at 2 1/3, right? So I'm moving this point now 2 units to the left and kind of here, right? Now that is how it is going to be, right? So this is the kind of graph which you are expecting as a final graph before translating up, right? So that is, we have done the inside part. So this gives you minus 3 to the power of minus 3x plus 2. So that is this graph. And finally, we move it one step up. Do you see that? So finally, you move it one step up. So this point comes right there to this point, right? So everything moves by a step up now, right? So we kind of get a function, but we get a horizontal asymptote at 1. So let me first draw the horizontal asymptote at 1. That is my horizontal asymptote at 1. And let me finish this graph with, okay, so we are very close to this line, so our graph will be kind of like this. And that is the function f of x, which is minus of 3 to the power of minus 3 x plus 2 plus 1, right? And this is y equals to 1. Now from here, well, I've shown you all these steps only to tell you two things. One, how do we do transformations, and how do we answer the questions, right? Now from here we can easily see the domain. Well, domain of exponential function is always real numbers, correct? So that was never a doubt. We could have done that even without doing all this, right? So we have first, which is domain. Domain is x belongs to real numbers. There is no restriction on domain of any exponential functions, right? Now as far as the range is concerned, range is, we know we have a horizontal asymptote. Since this reflection is there and there's one translation of 1 unit up, we could have straight away written range as y belongs to real numbers, where y is less than 1. It's never equal to 1, it approaches as a horizontal asymptote, right? We could have given this answer right from the question itself without doing much. But here, I think I took some time to explain you how to sketch these types of questions, since I wanted to really give you a question on transformation, that is, show transformations. And then answer the question, okay? So that is why I took time to show you transformation. This is an excellent example to sketch the function. So treat it as a problem for sketching a function and then writing domain as a subset or a part of it. That will help you to understand this function much, much better. I hope you appreciate it. Thank you and all the best.